Welcome! In this webinar, we'll show you some of the new features of ProcessBook 3.2. We'll build an element relative display that is going to contain references to multiple dynamic objects out of the AF database. We'll use some of the new features such as the playback toolbar and the navigation toolbar that are found in ProcessBook 3.2. We have here in the manual the problem description, and what we've been asked to do is to show various production statistics from our reaction train. We want this to be an element relative display because we may have several of these components of these reactors in the plant, and we want to produce a display that can easily be used to display data for any single one of these components. What that means is that by producing only one display, we'll be able to produce or to display the data for any one of these components, as opposed to having to create a display for every single one of them. And we'll see how that works. So let's go to our machine and open our AF database and look at the database that we'll be working with. Once PyExplorer opens, we'll be able to select the database. In this example, if we go to database, training sample, this is the database that we'll be using for this specific lab. I click OK, open the database, and by going to elements, I can see some of the elements that I have in here. They are divided by division and geography. We have in Houston a chemical division, and we have an equipment list, and under that equipment list we have reactors, and we have two different reactors. We'll be producing the display for Houston reactor 101, and that display will also be able to read data from reactor 102 or some of the reactors in the other locations. So in ProcessBook, we'll be able to select which reactor the display is displaying data for. So let's close the AF database and open a template that will facilitate the construction of this display. There is a folder called Labs under the C drive. We can go to ProcessBook, New Features, Template, and open the Element Relative Display template. The first thing that we are going to do once the template opens is to establish a connection to our Pi server, and then to ensure that we are also connected to the correct AF database, which in this example is training samples. So let's go to File, Connections, connect to our Pi server, under View, Element Relative Display. That will open this docking window. We can click on the PyExplorer icon and ensure that we are connected to the right database. We have AF Systems, this database selected. If we do a search, we can see all of the elements that we already saw in the AF database. We click OK. We know we are connected to the right database, and this is the template that we have for our reactor, and we have certain attributes that we want to show, such as the product, the density, volume, and mass of the component of the compound inside this reactor, and we also want to plot temperature information. So in order to start working with our display, let's go ahead and type reactor in our filter box, and this is going to display all of the elements that contain the name reactor in it, including our Houston reactor number 1, which we want to use to construct our display. Now that I have selected the Houston reactor number 1, I will first go ahead and plot the temperature for that reactor. By double clicking on the display, I can go ahead and do a tag search by element relative criteria. By clicking on that element relative criteria, I am taken to this dialog window where my reactor that I selected on this element window is already displayed, and I'm also shown the attributes that I can select to display on my ProcessBook. What I want to display from here is temperature. The way I select these attributes is by highlighting the one I want and clicking on the down arrow. I can expand the temperature, and I want to select all of these values: lower temperature, typical, and upper value. I click OK. Make sure that I have the correct range. Let's go ahead and do a 12-hour range, full time stamp. Everything looks good. Click OK, and I have my temperature being displayed. Now I will do a similar operation to add values to my product density, volume, and mass. To do that, I go to Draw, Value, and do a search by element relative criteria, and select the product, down arrow, make sure that it's selected as an attribute, click OK. Everything looks good here. Click OK one more time, and now I can change. Let's go to a font of 16 and a color black so that I can see it, and I have my product that is contained in this Houston Reactor 101. I will go ahead and do the same to add density, volume, and mass. Here we are, element relative display. What I want is the density, and I have density here. Select density, click OK. I'm going to show the units also for the density. Click OK, and I can use the menu to increase the font and change the color to black. And I will do this process 2 more times to add the volume and the mass. Element relative, I want the volume, I can change the font to 16, the color to black, and do it one more time. Element relative, and I want the mass. Click OK, show the units, increase the font, and change the color to black. Okay, now that I have that, I also would like to add a title to my display, and I'm going to do that using the value function, also doing an element relative search, and I can click on this add element name, click OK, OK, and I have the name of the element. And that's also a relative value, meaning that when I select a different reactor, the name is going to change, and also the product being displayed, and each one of these attributes, including the graph. And we'll see how that works. Now I would also like to show an indication of the level in my reactor in 2 ways. One is by showing a value below the reactor. So I'm going to select again level, click OK, show the units and also the timestamp at the bottom of the value. I'm going to change the color of the font to black, try to align this a little bit better, and also provide a graphical display of the level using a bar. and selecting level as the element that I'm going to display here. Click OK. I can always right click and go to format color. Maybe make sure that the lines are black, that the background is empty so we can see right through it. I can make it look nicer by going to the symbol library and maybe adding a scale to the top of this bar. There is a section here in the symbol library that has different scales. We can select the scale from 0 to 10. That looks very nice for my indication of level. Now that I have completed my display, I can go ahead and save it. I can also add this element to the navigation bar, which is one of the new features. I can see here how this browser type of navigation bar allows me to go to previous displays that I had open in ProcessBook, and I can easily navigate from previous displays to the one that I'm working on. I can also add it to as a bookmark. I can also open the bookmark organizer and see what displays are being shown in there, and we can see that this display is already saved as a bookmark. Another feature that we can use in ProcessBook 3.2 is this play menu or toolbar that allows us to easily change the range that is being shown or displayed in ProcessBook, and I can see how I can extend, I can decrease the range that I'm being displayed, and I can also click on the play button and show the temperature moving in time for the range that I selected. I can pause, I can stop it, I can repeat or revert back to my previous state. Now, the importance of these element relative displays is the ability that they provide now to show us or to allow us to use this same display to display data from other reactors. We created this display with Houston Reactor 101, but now if I select Houston Reactor 102, I can see that the same display updates the information to what's contained in Reactor 102. So I can see that the name change, the product that is there, the density, volume, mass, each one of those values now it's reflecting what's in Reactor 101. I'm sorry, 102, and I can easily switch to any other reactor across different divisions or geographical locations. So for San Leandro Reactor 101, 102, now I can easily browse through any of these reactors that are contained in my AF database.